Hi, everyone. I'm Neil Voloshin, CEO of Cavitation Technologies, Inc. And Eric, thank you for having me at Buffalo Fireside Chat's virtual conference. This is the first time I'm at your conference, Eric, so I'd like to cover with you a lot of things that our company does and our business moving forward, the opportunities that I see in front of us. So a little bit of history. So we go back to how the company started. The company, was formed in 2007 and became publicly traded in 2008. So we've been in business for quite some time. If you look at it, what our company is, where we are, we have 1 million shares authorized, approximately 300 million shares outstanding. Of those 300 million, our free float is approximately 200 million. We do not have any convertible debt or any toxic financing. We do have $150,000 SBA loan, which we're currently paying at about $750 a month. So other than that, we're current across the board. We've been current across the board filing our Qs and Ks. So this is a little bit of a synopsis of our corporate structure and where we are as the enterprise. Now, let me cover a little bit what our technology does. The core principle behind our technology is cavitation, flow-through process. To conceptually to understand what it really does, for example, a metal pipe. Inside of metal pipe, we have various insertions, metal insertions that have various openings and configurations. The fluid is entering from point A and exiting through point B, which takes typically just a fraction of a second, goes through various changes. So at that point, because of a high-low pressure that's being created inside the pipe, the molecular structure and physical structure of fluid is completely broken. So what does it really mean, and why is it even important? The fact is that we do know in the basic chemistry that to accelerate a chemical reaction, the particle size and the temperature matters to accelerate any type of chemical reaction. So what our technology does is the following. Because we break the fluid to nanoparticles or micro vapor bubbles, the particle size becomes tiny, tiny, tiny. And at the molecular level, the temperature rises to 2, 3, 4,000 degrees Celsius. So at that point, if we want to accelerate any sort of chemical reaction, we also need a fraction of any type of catalyst to achieve the desired matter. So our technology itself is a flow-through process. It's not a batch process. So the various flow-through capacities that we offer to our customers or end users range anywhere from 10 gallons per minute to as high as 500 gallons per minute. And technology is applicable to, again, multiple industries. We go from vegetable oil refining, hydrocarbons, any type of water for fluid processing or water remediation, alcoholic beverages. In recent years, we've developed our new technology, cavitation non-thermal plasma. We do believe that this particular technology is really a breakthrough. The concept is, again, we have our cavitation process, and that's kind of like a pre-treatment or a startup. And then we have plasma, which is today considered, fourth state matter. So in essence, it's almost like a lightning going through a fluid. But that's the reason it's called non-thermal. The advantage of it is the following, that any type of organics, bacteria, or viruses will be entirely annihilated by using non-thermal plasma. So the applications or industries that, non-thermal plasma could be implemented are just as many as we can possibly count. We can go into electronics, we can go into agriculture, foods, just water remediation. So the list will go on and on and on. And because technology itself or the system itself is very compact, it's probably 150, 200 pounds, about 4 feet tall, could be installed at the existing operation within 30 minutes. Be easy to install, run, it's all fully computerized. So we do believe that this particular technology could be breakthrough because, again, for example, in the industries where UV lights are being used, there is really no physical contact of the UV light and the fluid. With our particular technology, it is a physical contact. Initial research indicates to us that the process itself, the non-thermal plasma process, is by far more efficient than, for example, UV lights. So our technology all in all, including our core technology, which is cavitation, non-thermal plasma, is a true green technology. The reason I mentioned that because part of the advantages that cavitation technologies provides is really elimination or significant reduction in usage of chemicals. As I've mentioned to you earlier, that the chemical reaction, or let's say if it add any type of catalyst, will require only a fraction of what the typical or stoichiometric amount would be required through a conventional process. In some instances, for example, we will eliminate usage of chemicals entirely. In some instances, we'll use it by as high as 80%. So we're truly green technology, green technology company. And again, the end result is a significant reduction of operating costs for the end user. About 4 or 5 years ago, our company made a little bit of a shift because we primarily started focusing on water treatment, water remediation applications and industries. In the past, for example, one of our great strategic partners, Desmet Balestro Group and Alfa Laval, our seller of a technology, vegetable oil refining, including biofuels. So about a year and a half ago, we sold some of our patents to Desmet for approximately $1 million, Desmet and Alfa Laval in essence. And we still have a little bit of a presence in vegetable oil refining, but not as much as we've had in the past years. Primarily, again, we discussed the fact that water treatment gives our company a huge opportunity. In about 2019, 2020, we did make our first footprint in water treatment space, and that was in the oil and gas industry. We did have commercial applications in that space. We did receive certain revenue. Unfortunately for us, the industry has shifted a little bit to more of an enterprise type of play from modular systems, and it took us several years to readjust our business model and bring a couple of more partners. This is something that we're exploring today as well. Meanwhile, what we're looking for right now is mainly the focus would be on our non-thermal plasma, cavitation non-thermal plasma. Sometimes we call it CNTP. And the reason for that is, again, today the need for clean water is just the paramount. We believe that non-thermal plasma, again, can really change make a fundamental shift the way the industry is treating water. For example, we've done some research in our facility. Our tap water, just supposedly, when we're in California, supposedly it's drinkable, that water is drinkable, or pass it through our non-thermal plasma system. And the results were the following, as you can see on the screen. You have a glass of clear water, that's our tap water. Several days later, the tap water still remains the same. There are no changes. And the next glass to it, as you can see, this brownish kind of color inside the water, that was something running it through non-thermal plasma. We've made these separations of some heavy particles. Of course, a day later, you can see the water becomes clear, but you have a settlement in the glass. So that, in essence, what non-thermal plasma were able to do as far as cleaning water. So in essence, again, think about it. We were able to break the molecular structure, have plasma going exactly through water. It's a pass-through. And at that point, we were able to separate some of the non-organics, and those non-organics have become the settlements. The next slide, we can show you what we did with water when we infused some of the, a little bit of E. coli. And you can see that bacteria grew in the next several days, and you can see it as a spot. After the treatment with non-thermal plasma, there's no growth, no organics. So this is just the initial steps that we look into as far as what our technology can bring to the commercial space. Currently, we're running our system trials with several companies. One of the companies is Cargill. With Cargill, we're testing non-thermal plasma, and again, an elimination of organics, treating water. I mean, there are multiple applications of where we think that non-thermal plasma can work. So the process is underway. We shipped the unit to Cargill about a month ago. So we're just going through protocols and getting quite a few things done. The next project that we're currently looking at is BMI Group in Port Huron, not far from Detroit. In this particular space, we are bringing our core technology, cavitation system, and non-thermal plasma. The objective there is the removal or elimination of PFAS, which is forever chemical, Or perhaps we can do a separation of PFAS from the molecules because they're really, really tiny, tiny particles. And perhaps the conventional process of removal of PFAS will become significantly better or significantly faster. So those are two areas right now we're currently testing our systems. Those are underway, and let's say I'm looking for opportunities to commercialize things, what our non-thermal plasma can do. About 5 years ago, we've developed a technology related to treatment or processing of alcoholic beverages. Again, the technology itself is based on cavitation. This is not a distillation or filtration process. So we were able to treat fluids, or in that particular instance, alcohol, to a level where certain toxins or impurities in alcohol, which are always present, were significantly reduced or eliminated. So fast forward, what does it really do? Less hangovers, by far amplified or smoother taste of alcohol. For, let's say, cocktail preparation, because of the taste of alcohol becomes very, very smooth. The consumer doesn't need to add as much sugars or, let's say, simple syrup to cover up the taste of alcohol itself. And for wine drinkers, the objective is we see some analytics initially, that the reduction of sulfites. Wines are a bit trickier because red and white wines behave quite differently, but we can clearly see that the reduction of sulfites is taking place as well. So fast forward, what we did, we created a product called BarMuse. BarMuse is purely for the consumers. It is a smart appliance. It is operational through a mobile device, and consumer can really alternate the process to their liking or anything they would like to do with alcohol. The consumer can set up different times based on the alcohol itself, can pick and choose, make notes. The concept of the product will be similar to what Keurig and SodaStream did. And, Keurig was sold for $13 billion. We're shifting in a similar way in alcoholic beverages, where there is a device for a consumer, where a consumer can process the alcohol of their choice. And down the road, we're going to provide them with our own supply, for example, vodka, whiskeys, you name it. It is really going to be a razor and blade business model. And because it's a smart appliance, we can clearly collect a lot of data, what consumers really do, how they buy, how they process alcohol. We did make presentations at Amazon Launchpad. Amazon absolutely loved the product. As soon as we go to production, Amazon is going to be our first retail outlet. How did we arrive at that? About 10 years ago, we created our own brand of vodka, which we never commercialized, but we just wanted to at least understand where we stack up against the competition. What does it really do? Because we could clearly taste the difference in terms of smoothness of alcohol. We were rated #1 rated vodka made in the US, 95 points. You can see that at www.tastings.com. We're still #1 rated vodka made 10 years later, 95-point rated, and we're top 15 in the world. It literally takes us a second to make this product. Depict the fact of how technology works. It changes the molecular structure of fluids. Because of that, technology really elevates the value proposition for a consumer and provides much, much, much better product. Also, you can check out quite a bit of information on BarMuse and alcoholic beverages at alchemybeveragesinc.com or barmuse.com. You'd be able to see how the product works. The last segment I'd like for us to discuss is the fact that recently the company did announce that we are opening a new division, 100% owned subsidiary, focusing primarily on crypto space. For example, our non-thermal plasma technology, we believe, can make fundamental changes in treating fluids that are introduced today for cooling systems in server or IT farms. So the objective would be to, for example, recycling of those fluids that may carry, for example, PFAS. The same, we go through the same process. A reduction of impurities in fluid. That fluid perhaps could be, again, recycled and reused in the process. Or if it is disposal rate, then it's going to be a safe way to dispose. Again, no usage of chemicals. We believe that opportunity will come along. Sub that we form right now is called Zara. In the next, 6 to 8 weeks, you're going to see quite a few things that we're going to be developing on a crypto side. So stay tuned. We're going to be updating. At the end, I would like to thank Eric again. Thank you for having me on Buffalo Fireside Chat virtual conference. I think you're doing a great job, man, allowing small companies speak to the public. And that's, I think, just a great opportunity for us and for many, many small cap companies. Again, thank you for joining us today, and have a great day, everyone.